Hi, I'm Lindsay Pogue. I'm a 7th grade math teacher at Northwest Middle School in Travelers Rest. I teach 2 Math 7 classes, one inclusion math class and one advanced math class. This webinar is going to focus on creating a problem-solving culture in the classroom because my biggest weakness tip is tip 6. This tip is my weakest area because most of my lessons are teacher-led where the students just mimic what has already been taught. I do not give my students enough opportunities to explore concepts before they are formally taught. A normal day in my classroom would look like this. The students would come in, have a seat, get their materials, start working on warm-up questions, which are usually either a review of what was learned the previous day or an introduction to what is about to be learned that activates some kind of prior knowledge that they need for the concept that's about to be taught. Then they would copy down some notes, usually some definitions of words that they're going to learn that day. They will copy down examples as I work them out on the board, and if there's time at the end, they will have the opportunity to work out some examples on their own. And these problems are usually just the basic algorithmic math problems with right or wrong answers, not really any problem solving or relating to the real world situations. After completing some research on this topic, I realized that I'm not questioning my students in a way that allows them to explore, analyze, critique, and question what they are learning. So I decided to focus on questioning to grow my teaching craft in this area. The article I found is published on enrich.maths.org, which is published by Cambridge University. The author is Jenny Pinnett, and it was written in 2013. In the article, Pinnett challenges teachers to reflect on their teaching and determine who does the most talking during their lessons, whether it's the teacher or the students, who asks the questions, what kind of questions are being asked, and who answers the question. The article made me realize that I definitely do most of the talking during my lessons. I pretty much ask all of the questions, and my high flyers are usually the only ones who answer the questions or have any questions to ask themselves. A lot of times in my lessons, I find myself modeling how to solve problems, then allowing time for students to ask questions if they're confused, clearing up the misconceptions, and moving on. Most of the time, the students aren't even sure what kind of questions they need to ask, so they just write down what I say and move on to the next problem. Pinnett suggests focusing on questions during 4 parts of the lesson. The starter questions at the beginning of the lesson, questions that promote mathematical thinking throughout the exploration, assessment questions that determine what the students have found out and how they're doing, and final discussion questions to summarize what has been discovered. In my classroom, I'm going to try to use at least one higher order thinking question for each part of the lesson. For example, at the start, instead of using an essential question, which is pretty much just the learning objective turned into a question, such as how can I find the surface area of a cylinder, I'm going to pose a problem with an open-ended solution that my students can explore based on the topic that they're learning about. So, for example, if we're learning about cylinders, I can say, you are working for Campbell Soup Company. It's your job to design the soup can. How can you do this in the most efficient way possible? While giving students the opportunity to explore cylinders, their shapes, their nets, the shapes that make them, what surface area is, I can go around and ask questions, especially to the students who get stuck. Ask questions like, what shapes make up a cylinder? How do you find the area of those shapes? What does that have to do with finding surface area? What is your neighbor doing to figure out how to design the soup can? Are your strategies similar or different than your neighbor's? Is that the same or different than what your neighbor discovered? Why did you do what you did? For the final discussion, kind of as we come back together as a whole class, I can ask questions that bring everyone's solutions together to derive the formula for a cylinder and refer back to the starting prompt and how they can find a solution to that problem. While asking these questions, I will make sure to hear from all of the students, not just the high flyers, and allow the students to question each other, repeat and rephrase what each other have said, and build on each other's ideas. I will allow them to answer the questions just by talking to me, talking to their neighbor, writing their answers down as a part of their research, and writing down what other people say to include in their research. As an instructional coach, I can assist others in growing in this tip area by giving them some of the STEM questions that Pinnett has in the article to get them started on those higher order thinking questions. I can help them build these questions for any content that they teach, whether it's math, science, English, social studies, anything really, and I can help them change their didactic, right or wrong answer questions to more higher level thinking questions, and using questions that allow the students to compare and contrast ideas, explain someone else's thinking, analyze a problem, and find multiple solutions. And I'd also be willing to go into the classrooms with these teachers and show them how to ask these questions, how to let the students answer, give appropriate time for the students to answer, and let the students bounce ideas off of each other.